It's a pleasure to see an international audience of people from all industries and backgrounds and countries. Good to see you all. Great. And thank you so much for confirming. I would like to thank you all for registering and taking time out on a Sunday to learn about the topic, introducing the EERA, Escape, Evacuation, and Rescue Analysis approach with real case studies in COMAH Safety Case Report. My name is Aisha Khalik, and I will be your introductory speaker for today. It's a pleasure to host this webinar for you. Just for your information, this is our 99th webinar in a series of webinars that we are conducting every month. As a practice, we conduct one webinar every month. Please follow us on LinkedIn, YouTube, and follow our websites to check our website webinars and the latest updates about the webinars. Today, we have an experienced panel of speakers. I am with my colleague, Mr. Ijazul Karim Rao, who is the Managing Director, Principal, Integrity and Safety Consultant. Madam Mubina Khatoon, she is the Director, Engineering Services. Mr. Anthony James William, who is General Manager, Global Sales at Velosi. So today's agenda covers Velosi introduction, escape, evacuation, and rescue analysis, EERA, the topic of today, then standard and regulations related to this topic. And we will also cover case studies related to this topic. And at the end, we will have question and answer sessions to clear any doubts that you may have. So let us begin. I'll start by giving a brief introduction about Velosi and what we do. Velosi is a leading consultancy firm that provides asset integrity, management, HSE, and environmental engineering and software services throughout the world. Velosi Group was founded in 1982 in Malaysia, and it was acquired by Apple Spain in 2011. We have more than 43 years of experience in the asset integrity, HSE, engineering, and software development services. And our footprints have been expanded to more than 86 countries so far. Velosi has completed more than 1,350 projects so far with 500 different clients who are satisfied with our consultancy services.
Assalamu alaikum and good day, everyone. We know that this is a different time zone. People who are attending this webinar, it is early morning in America and morning in Europe. And there is afternoon here in Abu Dhabi. So today's topic is relatively easy and is a series of our webinars what we have been conducting on the HSE-IEA or safety case scope. And we have done QRA, we have done ESSA, now we are covering ERA. Next, a webinar would be on BRA, and then we will also cover FERA, FERA. So ERA is Escape, Evacuation, and Rescue Analysis. And it is clear from its title, when any facility, hydrocarbon facility, is being built, so we have to keep in mind, emergency or any accident is part and parcel of the life. If any accident happens or if any emergency situation arrives, then we should be able to evacuate people, or people should be able to escape from the scene. It is the last part of the layer of protection. And normally we consider there are 5 layers of protection, prevention, detection, control, then mitigation, and emergency response plan. The escape, evacuation, and rescue operation is part of the last layer of protection, which is called normally emergency response. So when we say what is ERA, our topic for our discussion is to understand what is ERA. ERA, it is by title, it's very easy: escape, evacuation, and rescue analysis. So how we do it as a part of safety case study or HSE-IEA part of COMAH report. So by definition, if I go a little bit, ERA stands for Escape, Evacuation, and Rescue Analysis. It is a technical safety assessment focused on evaluating the effectiveness of a facility's plans and procedures for personal safety, during emergencies. This is assessment ensure that people can safely leave the facility, reach a muster point, and be rescued if necessary in the event of a major accident. Now, there are like overview point of view, three aspects are normally ERA is defined by. ERA ensures safe evacuation, routes and rescue system are effective, then helps demonstrate that risks for personnel during a major accidental hazards are reduced to a low as reasonably practicable. It's a goal-based assessment where goals are set to escape, evacuation, rescue, provisions, and supporting systems such as detection, alarm, and communication aspects. So this is the definition. The last part is coming from the ADNOC standard. And since this protocol or the set of documents which are required to be produced for any new facility or to assess the situation of any operating facility with respect to the regulatory requirement of ADNOC. So this is one of the basically 6 goal-based assessment for the ERA. Now, what we normally focus under ERA is a personal protection, then temporary refuge. Temporary refuge is, for example, if there is a H2S release or any toxic gas like ammonia or chlorine, if it could release from any pressure containment, and if people has to take the protection, then there should be some shelter, like you can see in the picture here, where people can go inside the container and can be safe, and there would not be any ingress of the toxic gas in the system. The system would be totally isolated from the outside. Then it is also a regulatory requirement, like we have to have a safe ERA situation. And there are standards like international standards, OGP standards, API standards, and companies' own standards. Then one part which is very important is evacuation readiness. Like you can see that if there is a, let's say, fire or some emergency on any offshore platform, so there are like escape boats, like where people can sit in those escape boats and can be moved away from the platforms. Now, if we see how the requirement of ERA evolved over the period of years, so there was one major accident in North Sea in 1988. So there were many factors which contributed to this accident, but there are factors which are related to ERA we are trying to highlight. We are not discussing all the causes of this accident because there were multiple causes, we know that. But the contributing factors related to ERA, one was inadequate rescue readiness, delayed external rescue operation. This was one of the cause. The second one, the limited and poorly maintained escape routes resulted in many casualties. Then third one was communication breakdowns between the different teams and shifts contribute to the escalation. So this was 3 reasons which contribute heavily in the fatalities, increasing number of fatalities. So if ERA, like especially communication point of view, or accessible routes during emergency, and if there was external involvement was required, it should have been done in a timely manner. There is another incident. It was Killand, a disaster, it happened on March 27, 1980. The Alexander L. Killand accommodation platform capsized in the North Sea due to a structural failure, resulting in 123 fatalities. Right? The causes of incidents were various, but the increased number of fatalities which caused by this accident were also contributed by inadequate rescue readiness, lifeboat launch failure, and escape route inaccessibility. So these 3 reasons were also contributing towards the 123 fatalities in the North Sea. If we go another one, 210, Tesoro and Corrientes refinery disaster. Here, there were 7 fatalities, and which were caused by no defined escape routes, delayed rescue, insufficient muster and refuge areas. So here, if you can see, the role of ERA is becoming important and more important when we see the number of casualties which could occur due to any major accident. So just to check our readiness, because all of you are attending this meeting and some might be getting bored with a lot of technical discussion. So if we try to check ourselves, what is a primary objective of FERA? You people can answer this question in the a chat box, and then I will also show the answer. So here, what is the primary objective of ERA? To test the response time of rescue helicopters, to monitor regular worker movement pattern, to assess the functionality of escape and rescue systems during emergencies, to reduce the training time. So what is the answer? Please write in the answer windows, question answer windows, right? And some people are writing that. At least I found one wrong, mostly right. So the answer is B, to assess the functionality of escape and rescue system during the emergencies. So like last FERA, ESSA webinar, I took longer time. So this time on the ERA webinar, we are focusing to complete this a webinar within 1.5 hours. So target is to close it earlier before 4 o'clock, so as we don't don't move beyond our target time. So standards and regulations. So this is one of the important aspect. Whatever we do in accordance with the requirement of international codes and practices. It's not what Velosi is saying, what Ijaz Rao is saying. It's not up to us. The requirements are pretty clearly defined in various codes and standards. So just to get you familiar, you can go to these codes yourself and look at what are the requirements. One is ISO 7933, ISO 15554, API RP14J, API RP14C, API RP750. If we go to the standards, this is the ergonomics of the thermal environment, analytical determination and interpretation of the heat stress, calculation of the predicted heat strain. This is one aspect. And the other one is a little more relevant, oil and gas industry, offshore production installation requirements and guidance for emergency response. This should be the first standard as a reference. Then there is a recommended practice for design and hazardous analysis of offshore production facilities. This is another standard. The requirement which are covered under API 14J, if I may say, recommends minimum requirement for process safety information and hazard analysis, support compliance with API RP75 for offshore safety and environmental management, emphasize the need of sound engineering judgment, and complement, not override, existing codes and regulations. Next standard, API 14C, is the analysis, design, installation, and testing of safety systems for offshore production facilities. So form the foundation of functional safety design for offshore facilities, outline procedure for design, installation, and testing of both process safety and non-marine emergency support systems, ESS, on offshore production platforms, coordinate with API basically 17V for subsea systems, and covers process component from the surface wellhead to topside boarding valves. Then supports hazardous identification and mitigation through safety analysis and applies system level methods. Next standard, API 750, is the management of process hazards. So there are ADNOC, a full set of standards, which we take as a guidance and as a basic rules. And in ADNOC, all facilities, it is a mandatory requirement for all projects, which are the new projects. The full set of HSE-IA related studies is required to be produced. It has to be approved by ADNOC regulatory system, which is the headquarters of ADNOC. and is one of the exemplary system in the region, what we see, because we don't find this kind of robust system being used either by Saudi Aramco or Qatar Petroleum or other operating organization in the area. But now we see that a lot of lessons learned from the ADNOC are being adopted by the other organizations. So we feel very obliged or to working with ADNOC on these standards. So HSE-RM-ST07 is the ERA-related standard. Then HSE-RM-ST06 is basically related to COMAH, which is the controlling part of the standard. Then HSE-RM-ST03 is related to OHIT. And then ST09 is related to FERA. And ST10 is related to QRA requirement. It is a whole set of standards. And these are the only main standards we are trying to show here. Like this is the evacuation related, escape, evacuation and rescue assessment, FERA standard. It defines all requirements, all steps, workshop requirements, evaluation and goal-based approach. Then this is basically governing standard is COMAH, control of major accidental hazards. It defines all the requirements from hazard workshop to bow tie workshop, then QRA, FERA, BRA, and then this study basically. Then there is a hazard workshop, which comes basically hazard, invid, and OHIT. It is a standard which defines the requirement of various workshops and what should be the objective and the worksheet of the workshops. FERA is like a part of just like a QRA and BRA, 3 quantitative risk assessment studies. And this is a fire and explosion risk assessment study, and the ST09 is the reference code. Then QRA, similar to FERA, but focus on the quantitative risk assessment. So now we move towards the ERA case study, because today our slides are not many. So we will have question answer session at the end of the case study. So the project, what we are presenting part of, and it involved hazard, invid, OHIT workshops and reports, bow tie workshop and reports, HECS SC register and performance standards, then update of the integrated QRA, fire and explosion risk assessment, FERA, then emergency system survivability assessment, ESSA, escape evaluation and rescue assessment, FERA, then toxic gas dispersion modeling, COMAH report, review of existing company HECMS, EIA report, including PPC, ORA, HECIA dossier. So if you can see that ERA is part of this deliverable. Now, if we try to see as a part of the normal HECIA protocol, which is adopted by ADNOC, here data collection, then we have OHIT, INVID, hazard workshop, HECIA workshop and reports. Then there is a hazard classification, non-MAH and MAH. Whereas non-MAH we cover through HSE-MS, and for MAH there are further set of studies which are required to be executed, including ORA, EIA, air noise modeling, QRA, FERA, SIMOP and MOPO, ESSA and FERA, and COMAH report and HECIA complete dossier. So these reports also covers, if you say major accidental hazard, same detail is further provided, like QRA study report, FERA study report, ESSA study report, ERA study report, H2S zoning, along with that HECS register at feed stage, detail engineering stage, operation phase, and then HSC critical activity register, and then alarm demonstration also there, risk reduction measures, cost benefit analysis, and emergency and facility response plan, which is practically correlated with ERA. Our approach, we first carry out the ERA is we don't do as a one of the part. It can be done even, but we try to cover from A to Z aspects. The first, there are 3 workshops like a hazard, INVID, and OHIT. Under hazard, we covered hazards identification, and then terms of references are issued, workshop is executed, and then under workshop sessions, we try to identify the hazards in accordance with ST03 standard. In this particular project, we have identified various kind of hazards like high risk hazards under hazard none, but overhead 20, and high and medium risk hazards under hazard 5, under invalid 03, overhead 123, medium risk hazards like 93 under hazard, and under invalid 36, overhead 117. Then low risk hazards are also there, and no recommendations, number of recommendations, sorry, 17, 11, and 26 against hazard were 17. Now, when we try to go bow tie, so in general, we try to cover 5 layers of protection. Now, as per the ADNOC HSE-RM-ST07, there are 8 basically layers of protection. They are further subdivided, but these are like prevention, detection, control, mitigation, and emergency response, right? These are the 5 layers of protections. And then these 5 layers of protection we try to cover under bow tie. Here we can see the prevention side and mitigation side, and there's a top event in the middle, right? So here we can audit for critical activities, development of performance standard for safety critical equipment and system, then job descriptions and availability of SOPs are prepared accordingly for the better control of the bow tie activities. So here we try to identify various barriers on both sides, threats and consequences. Consequences are mitigated by, let's say, fire and gas detection system, passive fire protection system, or other mitigation measures, whereas threats are controlled by better design and by having better inspection, maintenance, and other activities. So here, if we see there is a threats, various controls, and top event consequences and various mitigative controls, those are shown in a basically graphical way in the bow tie. So in the bow tie analysis, we try to show also like as a threat in incorrect design, then design as per DGS or AGSs of ADNOC, then design review by like a PMC, PMT or ADNOC or the third parties, then malfunction of the like a burner management system, then it should be managed by inspection and the maintenance. So there is a threat. Along with that, what corrective action should be there. Similarly, if there are like a consequences, then how consequences are being mitigated, like a facility response plan, regular mock drill, and to be ready in the case of emergency occurs there. So next, like all those like a previous layer of protections are defined into 8 now: structural integrity, process containment, ignition control, detection system, then protection system, then shutdown system, emergency response, life saving. So these are the 8 basically layer of protection, and these are further there are HSE-CS barriers or SCE barriers, and then SCE categories. These are total 74. And same like if we say the various MAH, if we try to see, and then MAH are further subdivided into SCEs. So ER08, if you see emergency and escape lighting, and ER03 is emergency communication system. 2 HECCS are brought into ERA part, which are part of HECCS barrier identification. So now how we categorize those barriers, like like a barrier is belonging to prevention, detection, control, or mitigation, or as per the new like a foundation pressure containment or detection system here. So here acquire asset specific HECS categories from COMAH, download asset register. Then we try to find, does the boundary have a role in prevention? Does the location tag have a role in detection? Does the location tag have a role in control mitigation? Does the location tag have the role in emergency response plan? And identify the like a location tag as a non-HECS. In this way, we try to identify, then based on their consequence rating, we identify which item is HECS, which one is not, and this way identification of all HECS tags are done in the asset tag register. Now, if we try to just to refresh our memory, like how FERA is done, right? Because after FERA, we go to this stage. First hazard workshop, then we go to like identification of bow tie wise, like a major accidental hazard and non-major accidental hazards. Then FERA methodology and assumption register is prepared. Fire and explosion, basically hazard identification is done. Then fire and explosion calculations and evaluation done by using the software like FAST and SAFETI. Then accidents curves like a feasibility check. Then active and passive fire protection system is evaluated. Then fire and explosion risk assessment is done, and conclusion and recommendations are made as per the FERA study. Here, under FERA, we try to see fire and explosion hazard identification, failure case scenario selection, isolatable sections, consequence assessment, frequency analysis, fire and explosion risk analysis, then accidents curves feasibility, active and passive fire protection adequacy check requirements, and fire and explosion risk assessment and FERA workshop is done at the last stage before the report is issued. Then we go to COMAH report. COMAH is a control of like a major accidental hazards. It is also a live document which is updated at EPC stage, also at operation stage, and also post-operation stage. So here, major accidental hazard identification using formal hazard identification and bow tie analysis, this is done. Then identification of, like practically in this particular project where we worked, 41 MAH identified and 12 new MAH from current HSE-IA update, other retained from the previous HSE-IA. Then qualitative bow tie method used to identify control to prevent threat escalation and mitigate consequences. The 9 new bow tie developed, reflecting field modifications, management of change, reviews, and incident register as part of the HSE-IA update. So this is a report. So we are referring this is what we have done at the operation phase. Now, under QRA, we like a QRA evaluate hazard frequency and consequences to estimate risk numerically, calculate levels meet ADNOC criteria and are considered as low as reasonably practicable. Then like a quantitative assessment was conducted for all major accidental hazards at the facility. Then S2S zoning is also performed. Then ESSA, which is Emergency System Survivability Assessment. We conducted this like a webinar a few weeks ago. And under this, what we try to do, I'm just refreshing, HECS SE that support emergency response for the facility. Then next was assess vulnerability of HECS SEs and their components against identified major accidental hazards, MAH. Determine whether vulnerable systems are inherently fail-safe. Like if anything goes wrong, if the ESD valve would be able to close and BD valve would be able to open, and control valve fail-safe positions are known to the operators and to the system. Then check for redundancy. Then measure where systems are vulnerable, not fail-safe, and lack redundancy, and we need to make recommendations accordingly. Then over today's topic, escape, evacuation, rescue analysis. Here, initiate ERA, facility description and emergency escape and rescue measures, major accidental hazards which are identified, then endurance period calculation, then goal 1, for example, alarm and communication, goal 2, escape, goal 3, muster, goal 4, temporary refuge, goal 5, evacuation, and goal 6 is rescue. Whether we will be assessing the goal-wise each position, then see whether goals are achieved, then provide recommendation if goals are not being achieved, then we conduct emergency escape and rescue workshop, then emergency escape and rescue analysis report and action plan is being basically delivered. So here, ERA is a goal-based assessment for escape, evacuation, and rescue system. It assesses if these goals are met for identified major accidental hazards. Goals ensure effective EER performance for timely and safe personal escape. Now, case study point of view, the ERA assessment was conducted as a part of HSE-IA update for the gas facilities in alignment with the ADNOC HSE-IA standard. This update considered facility modifications, expansions, and changes, and ensured compliance with ADNOC ERA requirement as per HSE-RM-ST07. So the facilities what we covered: gas gathering system, product pipelines, gas processing plant, and sulfur handling stations. So ERA goals, which were defined same, like goal 1, alert and communications, goal 2, escape, goal 3, muster area, goal 4, temporary refuge, goal 5, evacuation, and goal 6, rescue. For example, if I try to cover like rescue mean enable the recovery of personnel using safe and immediate rescue methods, include standby medical support at safe locations, and account for all risk factors to rescue and evacuees. Similarly, if I try to cover like escape, maintain safe, possible and well-fit escape paths from any location to muster point or TRM temporary refuge, considering injured personnel and alternate routes for the impaired scenarios. So similarly, like I'm not reading all the goals, but there are 6 main goals and there is a target what we need to assess. Then accordingly, the report and assessment is performed and workshop is conducted. A key objective, like for example, as one are the goals, but there are 5 key objectives. Means emergency communication. If there is emergency, whether the operators, the staff, the management, the neighboring facilities, the civil defense, hospitals, if there is some communication made to all parties involved, all stakeholders, so as required action and support could be provided during any emergency. Then escape route accessibility, whether like during the emergency, the escape route would not have been blocked. Then refuge and muster points, whether refuge and muster points are known to operators and the people in that particular area, and if they would be able to reach there. Then if some injury is there, whether we would be able to evacuate the injured person to the hospital and other safe location. Then this is part like rescue and recovery system exists to recover and transport evacuees to place of safety. So these all parts like evacuation arrangement and rescue and recovery both are correlated, but these are the objective of the ERA study. Now, what measures like we try to bring in, like as per the HSE-RM-ST07, there are 6 basically EER, like emergency, escape and recovery measures, like a facility response plan should be available. Number 2, FNG mapping study should have been done, so as FNG can tell if there is any leakage or there is any fire in the particular area. Then telecommunication philosophy and the system which communicate, a PAGA system or beacon system which provide information to the all basically stakeholders. Then overall escape route layout, existing FERA study report, then ERA workshop worksheet. So these are the measures which helps us to assess like the 6 goals what we set for the ERA study are being met by the operator or by the operating company or not. Here, if we see that area-wise, so we have further, like we are not covering all areas, but we are showing you only sulfur stations as a sample study. Here, like a first goal is detection, alarming, and communication system. This is the first basically aspect. There are multiple installations for the adequate coverage of alarm and sounder communication system like Tetra radio system, public address PAGA system, like a general alarm system, closed circuit television, CCTV is also there, then telephone system, VoIP is also there, alarm system is there, beacons are there. So this is the first like aspect. Then escape routes, like a 4-way escape routes are provided within the sulfur load stations. 3, open area mustering stations are provided within the sulfur station. Then TGR and SIP and IES buildings, there is 1 designated granular control room building in the sulfur station. Then evacuation measure and rescue measures were also in place as a part of the assessment. So here, like ERA study approach and key evaluations. Methodology, ERA study follows ADNOC like ST07 using a goal-based approach to assess the escape, evacuation, rescue system and supporting elements like alarm and communications. Assessment, it evaluates the effectiveness and adequacy of the system such as detection, alarms, and communications in meeting safety goals under emergency condition for identified major accidental hazards. Then assumptions, a gap analysis for the previous ERA report was conducted. Its findings serves as the assumption register and are included as an appendix in the current ERA report. Here, approach point of view, same, like as I discussed earlier, I think is a repetition. Initiate ERA, facility description, and like EER measures, MH identification, endurance period calculations. Then there are goals, like a goal 1, alarm and communications, goal 2, escape, goal 3, muster, goal 4, temporary refuge, goal 5, evacuation, goal 6, rescue, goal achieved, or there is a not achieved when recommendations are made. Then emergency escape and recovery workshop, then ERA report and action plan. So the hazards which were identified for the sulfur unit were 5, MH37, MH38, 39, 40, and 41, fuel gas area, like loss of fuel gas from unit 2021, loss of fuel gas from unit 202, liquid sulfur piping pump leak, then dust explosion, then new MH identified HSE-IA as per 2020, new MH identified HSE-IA as a 2020. So tags and other identification is changed, so as we are not reflecting actual situation. So here, what major accident events are considered? Jet fire is considered, pool fire is considered, flash fire and flammable gas is considered, toxic gas release is considered, then overpressure explosion is considered, and tank fire is also considered. These are the 6 major accidental events which may occur in the facilities. Then, like against each, basically, we say that major accidental hazard. So what kind of scenarios are there? Like a fuel gas system, there are the jet fire, pool fire, flammable gas dispersion, the vapor cloud explosion is not considered, tank fire, dust explosion, SO2 gas dispersion. So these various scenarios of the fire and gas are considered applicable on this particular facility. Major accidental assessment point of view, what is the criteria of the impairment, like if escape route are not exposed to greater than 6.3 kilowatt per meter square. Explosion point of view, the load should not be exceeding 0.2. Toxic gas release not greater than 100 ppm LFL. Then for flash, basically fire should be LFL limit to be followed. Then SO2 dispersion also 100 ppm IDLH. So then evacuation measures also there is target, and temporary refuge requirement also given. The TR shall be protected from hydrocarbon fire for duration of 60 minutes or endurance time, whichever is greater. The protection shall be against both flammable impingement and engulfment and radiation levels. So these are the basically criteria which has been defined as per ADNOC standards. And then duration point of view, like in case of any escape, how much time would be spent by each, and then whether the escape apparatus or as long as the TR locations are concerned or rescue apparatus is concerned, that should be sufficient to support the total escape time. For example, we have a distance from the safe location, walkways, vertical distance, travel distance from this, alarm time, then there is the EBA down time, and then total escape time in seconds and total escape time in minutes. Those are covered, and accordingly it is checked that people would be escape the facility within the escape facilities. Sulfur station, this is a GCR building, the same total escape time. Now, goal assessment wise, there are 6 goals. So we have assessed one by one. For example, goal 1, alarm and communication objective. Alert personnel of emergencies and maintain communication with emergency control centers. FNG detection coverage was optimized by relocating and adjusting detectors placement based on the mapping studies. Then achieved near complete area coverage post optimization. Then telecom system designed for high reliability and availability. Key substation include Tetra radio, then PAGA, and CCTV and telephone systems and beacon systems were effective. Conclusion, goal 1 is achieved. Comprehensive and reliable alerting and communication instructions is in place. Goal 2, like it is not in order. Goal 5 is evacuation. They're arranged based on the assessment. The evacuation, goal 5, ensure all personnel can be evacuated safely during an emergency. The evacuation vehicle, including standby units available as per the facility response plan. Then emergency response team, ERT, ensure evacuation coordination. Injured person transported using dedicated ambulance to on-site medical facility. The conclusion, goal 5 is achieved. Sufficient evacuation means are available for safe personnel evacuations. Then rescue personnel and rescue is a goal number 6. Rescue personnel and transfer them to place of safety with medical support. So head count conducted by ERT, dispatcher post evacuation, search and rescue operation performed by tactical response team, on-site medic team provided first aid, injured transferred to medical clinic 14 kilometers away or external hospital as needed. Conclusion, goal 6 is achieved. Rescue operation and medical facilities are well established and responsive. Escape. Objective, enable safe and rapid movement from the hazard zone to a safe zone. Escape route assessment confirmed availability and safety under key scenarios. Jet, pool fire, no impairment to escape routes. Flash fire, maximum gas dispersion 6.03 meters, does not impact escape way. Then SO2 dispersion, while one route may be impaired, alternative route remain available. Then dust explosion, no impact on escape routes. Conclusion, goal number 2 is achieved. Escape routes are clear and viable under all credible emergency scenarios. Muster, the goal number 3, provide safer muster areas for personnel during emergencies. SO2 dispersion modeling showed impairment to one muster point in specific wind conditions. Alternate assembly points available and accessible. Assembly areas size for full personal capacity and designed for protection during emergency operations. So goal 3 is achieved. Toxic H2S gas dispersion is not applicable here because it's SO2 area. So now temporary refuge impairment assessment. So here what we checked, that distance of the granular control room from the releasing source of sulfur station. So sulfur storage tanks, like approximate distance from the releasing source to the GCR. GCR building is not impacted by the MA scenario at the sulfur station. Therefore, goal 4 is achieved. However, SO2 gas detectors should be installed at appropriate location within the GCR building. So here, the 4 scenarios: pool jet fire, no impact from the radiation or fire engulfment at GCR. Similarly, maximum dispersion distance 5.74 meters does not affect GCR. Dust explosion, no overpressure effect at GCR detected, no impairment observed. Then SO2 dispersion, AEGL02 level dispersion could reach GCR. This is applicable. Worksheet. So here basically is the worksheet where it was discussed during the workshop here regarding sulfur recovery area. The escape, the functional requirement, current EER measure and supporting system, major accidental hazard, and thermal radiation. Here if we see goal 2, escape route must be remains possible in case emergency. Alternate escape route must be available in case MAH impairment. Escape routes easily identifiable with suitable sign and marking a proper illumination. Here, what is the safety designated escape routes? 03 ways escape routes are available for sulfur station. Then sulfur storage tank, this distance to escape way north to 77 meter, distance to escape way east 62 meter, distance to escape way south 175 meter. So these basically MA37 description fuel gas system, event loss of containment. So with this basically MAH, these are the basically goals which are being achieved. Similarly, the next goal 3 is assembly points which are checked and they are designated at the sulfur stations, right? And the sulfur tanks, the distance is this much, and the 3 muster stations and are designated in the sulfur station area. So goal number next goals assess granular wet source fuel gas facilities. Here the LFL limit is basically 6.034 meter. Then fuel gas facilities pig launcher, the LFL limit is 0.5. So these are distance. The thermal radiation and exposure, the far jet, pool and fire explosion events, all the escape routes are safe. 100 ppm SO2 dispersion could a cloud is not generated in the breeze armored software. Then 100 ppm H2S gas dispersion event not applicable, hence no further ER assessment was required. Goal is considered to be achieved, and goal is considered to be achieved here as well. Now, result point of view, here in sulfur stations, goal 1, communication, yes, achieved. Goal 2, thermal radiation explosion and toxic gas achieved. Muster, thermal radiation explosion and toxic gas release achieved. Then similarly, goal 4, temporary refuge. Goal 5, evacuation, and goal 6, rescue, all considered achieved basically. So not applicable. So here conclusion is all goals are achieved and no further assessment and alarm demonstration is required. So here a sulfur station ERA results alarm and communication, evacuation, rescue, escape, and muster. If I start goal 3, goal 2, goal 6, goal 5, goal 1, fire and gas detection coverage was optimized by relocating and adjusting detectors placement based on mapping studies. Then evacuation vehicle, including standby unit available, emergency rescue teams ensure evacuation and coordination. Then head count is also conducted by the ERT emergency response team, dispatch post-evacuation. This is a part of the drill. Then head count conducted by ERT dispatch post-evacuation. Search and rescue operations performed by the tactical rescue team. On-site medic team provided basically first aid. Then SO2 muster, SO2 dispersion modeling showed impairment to 1 muster point in specific wind conditions, alternative assembly point available and accessible. Now, ERA recommendation, all goals were achieved. No alarm demonstration is required. However, following recommendations were recorded. Impairment assessment of the thermal radiation and blast overpressure accidents curve for IES building need to be further evaluated with respect to MH identified in well-pad areas. SO2 detectors need to be installed at appropriate locations at GCR building in sulfur station area. So now, just to check, or webinar or presentation is over. Now, if we try to assess what we basically learned up to now, so we got various questions and we go one by one. You please feel free to answer those questions in the a question answer window. And after completion of these questions, we will also take live questions, and all of you would be free to ask your questions as much as you can, and we'll try to answer with our capability. So here, just a minute, which of the following is not a typical phase in the basically ERA process? Number 1, temporary refuge, rescue, evacuation, hazardous waste disposal. So which of the following is not a typical phase in the ERA process? So maximum people have added. So answer is D. Hazard waste disposal is not part of the ERA assessment. Now we go to the next question. The term rescue in the context of ERA strictly refers to retrieval of injured or trapped personnel during an emergency, retrieval of personnel to a place of safety post-evacuation, retrieval of personnel who have exited the TR and are unreachable, immediate recovery of assets following incident escalation. So the answers are being given by the people, but here I feel some different answers are coming, right? So the answer is basically retrieval of personnel to be place of a safety post-evacuation, basically that's called rescue. Retrieval of injured or trapped personnel during an emergency, that could also be an answer. but retrieval of the personnel to a place of safety post-evacuation, that is called basically rescue. So A and B could be the answer, but exact answer is C. Then what is the main function of temporary refuge, TR in ERA? Long-term accommodation for offshore staff, not right answer. Safe location of personnel during emergency before evacuation could be an answer. Area of storing safety equipment may not be an answer. Facility of conducting drills. So the answer is basically C, safe location for personnel during emergency before evacuation. Next question. A lifeboat is launched, but recovery time by standby vessel is estimated of 4 hours due to high wave. What does this challenge? The integrity of the muster process, ERA goal 3, evacuation, ERA goal 6, rescue capability, ERA goal 1, alarm effectiveness. The answer is 6. Like if the boat is coming after 4 hours, there would be no one left at the platform. It means the emergency boat should be able to reach within acceptable time, or the rescue lifeboat should be at the part of the platform or the barge, wherever this ERA is required.
So Mr. Charlie asked, could you provide a real-world example where temporary refuge impairment assessment identified a critical design flaw or operational gap in an offshore installation emergency response plan?
See, this question is hypothetical, right? Like if a TR is arranged for any facility, it means that any toxic gas, or there should not be any heat or radiation impact on that particular container where people are in. So these are basically designed properly and kept in an area where people are safe for a certain period. But if there could be a design flaw, for example, like air intake, for example, for ventilation purpose, and those aspects, if the not taken from a proper safe location, then there could be a issue. Otherwise, mostly it works. Okay. What is the standard for assembly point, where the assembly point should be conducted? So ST, the standard of ST07, I think is the standard for ERA. And ADNOC standard does provide one goal, like the muster point, where the muster point should be, and what should be the size of the muster point, and what should be the distance of the muster point, whether it would be in the safe location or not. So these all requirements are given in the muster point in the ST07 standard. Consider a scenario of a person standing on column, scrubber and H2S leakage occur. What is the ideal escape route? See, if the person has gone on the column without the proper breathing apparatus, there would be a casualty. Like I can give you one example. It happened at one of the facilities. I will not name the company. And EPC2 technician went to open a flange, and that's a piping flange connection. And there was H2S inside the flange. They took the detector of H2S, but they did not took the tight breathing apparatus while doing that activity. And there was a leakage of H2S from the open flange connection, and there was a fatality of those 2 technicians. So if we are dealing with any toxic gas, we have to take the preventive breathing apparatus point of view, preventive measure. So we should not be taking any breathing from that particular environment. Otherwise, there can be an accident. How does ERA ensure effective collaboration between industry and research? No.
Yeah.
ERA is not between industry and institutions. ERA is the collaboration between the industry, like operating plant management, their HSE response team, their operational response team, district management of that particular area, hospitals of that particular area, because the purpose of ERA analysis is how we would be responding to an emergency. If there would be a fire or explosion, then how the company would operate, work, and collaborate with the institutions, like a safety institution or hospital of that particular area, so as collaborative response could be given to the emergency, and emergency situation could be overcome. That's the purpose of ERA,
Right.
not a developing relationship between various institutions.
Right, sir. Thank you. Yes.
Wang Su Ning. Can you please unmute yourself and ask your question? We have given you permission to speak.
Hello,
Yes, please.
hear me? Yeah,
Yes,
sir.
yes.
Okay. Thanks, for organizing a webinar from Velosi. I always looking forward to all your webinar. Actually, I learned a lot. Okay, I have a question. It's about the detectors. Okay, when you presented, I think in one of the ERA slide, right, it's regards to the detector fire and gas mapping, and then ensure detector are provided, right? Based on the fire and gas mapping. And I have a question. Along your slide, I only saw SO2 detector. What about H2X detectors, sir?
Basically,
I wanted to know
it is a sulfur recovery plant where H2S all has been converted into either sulfur or SO2. So since there is no traces of H2S in the system, so that's why H2S detectors are not recommended. Right? SO2 is there. If H2S would be present, then H2S detectors are required, ma'am.
Oh, I mean, the reason is because no H2S but SO2 present,
Yes, yes, ma'am.
based on your case study presented.
Yes.
Okay. Because initially I thought because of, in some, cases, they are H2S and SO2 actually is part of the gas release from the chemical reactions.
Yes, if you can understand, both SO2 and H2S both are equally toxic, right? And if we have taking a protection against SO2, the H2S protection would also be taken, because SO2 also we cannot breathe and we cannot sustain. So both are dangerous gases. And if I have to recommend, I will recommend also add few H2S detectors also. But since dominant gas is SO2, that's why H2S detectors were not there.
Okay. Thank you, sir. Because I noticed the IDRH value are actually same with the H2S.
Yes.
Yeah.
Basically,
Alright. Thank you.
thinking is right, and it should be both, but that was the debate, and then decision was made.
All right. Okay. Thank you very much, sir.
Thank you for your question. Thank you. Next question. That could be maybe next question will be the last one before we close.
Mr. Rehan Jeffrey, we have given you permission to speak. Can you please unmute yourself and ask your question?
Okay, so I can read the question. This is the last one we can take for the day today. So what if we fail to step 1 in FERA study, for example, designing phase, then what impact this on the basically FERA study? Basically, the ERA is the outcome of the FERA study, basically. And FERA is able to tell us where is the impairment and what is the extent of the fire and explosion, and what kind of safety escape route we need to have, where we need to have some sort of, let's say, passive fire protection, and what should be the fire and gas mapping and so on. So practically, the output of FERA is taken into ERA study. And if some mistake is there, then of course we have given you 3 examples where major accidental hazards, accidents happened, and there were fatalities, and one of the major contribution was coming from the lack of ERA, or escape, evacuation and rescue operations were weak in those accidents, and those resulted in more basically deaths. Okay. Thank you very much for your questions and the interest. We'll be coming up next webinar that would be on BRA, Building Risk Assessment Study, next month. And by then, thank you very much, and keep sending your questions to us, and we'll be happy to answer you. Bye-bye for now.